You have done? I'll come check. Yep. Put a unit on it. If you don't like it, then you should have put a unit on it. Yep.
Was I right?
Yes, I just said put a unit on it. It's not technically right unless you put a unit on it, right? Or 0.73 cows.
Yeah, 0.7.
I mean,
That's like a
that's like 75% of a cow. I take that meat.
I do.
You bet.
0.73 potato costs. That's not very much potato.
Still working, Everett?
What if the world's got pretty big?
Okay, I would love to see units here so that I know that you know where you're putting stuff, not just randomly flopping stuff in places.
No, just potatoes.
And that's the back of the unit. I want to see that.
For the test, do we need to know these?
No, I'll give
Oh, I gotta write this down.
Good, sir. Well, I do need to show, you do have to show your work. Does that make sense? Now, I'm not going to get super crazy right now about it, but if you just, on a test or a quiz, if you just give me the answer and do not show the conversion factor, I will count it wrong, even if it's the right answer. Does that make sense? Remember, I'm grading on the process. I want you to tell me or show me that you can cancel out units correctly, not just because you're really good at math and can move a decimal. That's not what I'm going with. You're not going to be able to do that later on in later classes. Okay? Questions? Right. You got your homework in, hopefully?
No. Oh, no. What? Wait, homework. What homework? Oh, yeah.
Oh, yeah,
Awesome.
yeah.
More of that. Oh.
Yes. Can you go to the bathroom? Yeah.
So there's no
That's what I want. Good job. So you know, on a test, I want you to show all of that. Okay, good. Good, I think we got unit conversions. Pretty good. I was a little worried. I don't know if I can be close to that UD period, but we'll find out. Oh, too far. Whoop, too far. Oh, there we go. 3B, new section. Oh.
Yeah, 1 to 4 and 11. Yeah.
It's only Thursday, man. I feel like this week's going slow. I think it's going fast. It's going fast? Yes. Oh, you raise your hand because you thought it was going slow? It's going slow.
Yeah, Tuesday, I thought it was Thursday.
Yeah.
That's real slow then.
I thought Tuesday was Wednesday.
I thought Tuesday.
Got it now, Rose?
I wish Tuesday was.
Rose, you get it? All right, here we go. Let's begin. How is it that we only have clock just like zipping ahead? Okay. All right. Probably not earth-shattering new information to you, but measurements are never exact. Any idea what could be the reason why a measurement would not be exact, Ethan? Be more specific. I mean, yes, you are right. Yeah, and our senses aren't great, right? I mean, they're great, but they're not perfect. Okay. Thank you, Sam. I blame that. markings could not be small enough for us to get an accurate estimate. Because when you guys do a measurement, do you always land on like one of the tick marks? No. In fact, you probably hardly ever land on a tick mark, and you have to do some part or some aspect of estimating. Environmental error. Well, maybe you were trying to, I don't know. Trying to think of an environmental error.
Measure as much rain, but it impacts the
Yeah, that's a good example. You're trying to figure out how much rain came last night, but by the time you got to it in the morning, some of it had evaporated. That's an environmental problem. I mean, not a problem for environment, but it would have been some outside effect that you couldn't control. Server error, aka user error. It's like Dick McWilliams trying to count the birds in the air. It's very hard for him to do. Sorry. He gives me permission to make fun of him. He can't see. Is that an observer error? He looks out of the corner of his eye. He can see.
Yeah.
He can't see straight. He's got good peripheral vision, but he can't see straight. That's why. Like, if he
That's why when he has
reads,
his phone.
he looks like this.
Yeah.
Yeah, that's how he reads.
He has his phone right here. And
You ain't never noticed that? Did you know we played Ultimate Frisbee one year at Breakaway, and he played, and he could catch though. He could like look out of the corner of his eye enough to like see it and catch it. That is amazing.
Wait, so I think he had two back.
I mean, he probably looks like more like this. So like, it's not like looking.
Looks so
yeah.
cool and everything he
That'd
does.
be so cool.
It's gotta be like in his peripherals. Like, there's only a certain range my peripherals can go. Like, I can see probably straight that way, and I can probably shoot straight that way. But I can also use my peripherals to see kind of an angle. Can you guys see? If you look at your peripherals, can you see straight that way? Yeah. Okay, observer error. This is just due to a limitation in our senses. And instrument error. Oh, you're telling me instruments aren't perfect? Well, what are instruments made by? Humans.
Observer errors.
So everything's an observer error. And do things break down in instruments?
Yeah.
Yes. Do things can uncalibrate? Yes. Okay. Accuracy. We're going to really have to focus, main focus today is going to be on accuracy and precision. Once you get this in, I'll get you the next slide for you to put in, and I'll at once kind of talk about accuracy and precision, how they're similar and how they're different. Okay, so I'll let you get the next slide in if you have it. Can I move on? There you go. So get this slide in, and then I want to kind of together talk about how they're similar, how they're different. is actually the majority of our notes. That's going to be applying stuff, I think. Okay, got it so I can talk about it? What does that look like? An eyeball? Yeah, that's what I was trying to go for. It's like a dartboard. Not a dartboard, but like some sort of target. Yeah. Okay. All right. So here's accuracy and here's precision. Listen very carefully. Accuracy has to do with how close your measurement is to the actual measurement. So in the context of a dartboard or a bullseye, what would be accurate? Or being very close to it, right? Like if I have a shot that's here, 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 anything around here, you would say you're pretty accurate, right? Okay? And let's say I knew that a book was 24 centimeters long, and I measured 23.8, that's pretty accurate, right? But if I measure 12.3 or even 20.4, that's not very accurate. That makes sense? I have my North Dakota accent struggles me to say accurate. Okay. Here's precision. Precision has to do with your measurements. You are precise if all of your measurements are close to each other. Okay? So you can be precise and not accurate. Let me show you an example. Explain.
It's precise because they're all like next to each other, but it's not accurate because it's not in the middle.
Precision has to do with, are your measurements close to each other? If they're close to each other, you were pretty precise. You were way off the mark, but your measurements were precise. Okay? How about that? Both. Accurate and precise. Now here's the question. Can you be accurate without being precise?
Yes.
What?
Can you be accurate? Yeah.
Can you be accurate without being precise?
Yeah. Only measure it once.
Okay. Precision has to do with multiple.
Yeah.
Are you accurate? No. You got lucky on one, looks like. You're not, overall, you're not accurate. Took an average, you'd be like somewhere over here, right? Now, your book likes to state that there's one situation where you can be accurate without being precise, and I disagree with it. I call that luck. Here's what I mean. Your book would say that that is accurate. Why? Because if you took an average, where would you land? But if none of your things are anywhere close to the bullseye, can you really say you're accurate? No, just you got lucky. Unless you were intentionally trying to hit all those corners, and that was the whole purpose. But I don't think that's the case. Does that make sense? Okay? So accuracy has to do with how close you are to what you should have gotten, and precise is how close your measurements are to each other. So I would say that this is neither accurate or precise. That's what I would say. That's what I want you to say. I think that's better. It makes more logical sense. Don't you think? Does that help with accuracy and precision? It's not an overly crazy concept, but. All right, this is what I said earlier. How many measurements are exactly on a scale division or on a tick mark when you're measuring something? Yeah, I do want you to put in your notes. I want it to be fairly obvious that when you measure something, it doesn't land on your measurement scale every single time. In fact, a lot of times it doesn't. Now, the more precise your instrument, the more likely you are to land on something, but there's far more odds that you aren't than that you would. My son? My oldest. Okay, I've already talked about this. We'll move on. We're going to get into, I think this is the last slide that we have to write in our notes, because then we're going to start doing measurements. So this is just saying, how do we do measurements? What's the correct way to measure something? Well, so this is assuming a metric measurement, because it says 1/10. So essentially, you will go 1 decimal place beyond what you know. You always estimate to some uncertain digit. Get this? You're not getting that. This kind of is worded really scientifically. It's simpler than it probably is worded. Okay, here's really what this means if I break it down. When you're taking a ruler and you put it up to measure something, okay? Most often, you do not land right on a tick mark. So let's say you land halfway between the 5 and the first tick mark. Actually, let's do the metric system. It's a lot easier to deal with. Okay, let's say you land halfway between the 8 and the first tick mark. You would have to estimate where that would be. So you know it's at least 8.0, but it's between 8.0 and 8.1. So you would have to estimate that. So you're always going to measure up to what you know, the 8 you know, and you would have, and really the 8.0 you know, right? And you would probably say 8.05. Would that be halfway in between 8.0 and 8.1? 8.0 and 8.1? 8.05?
Oh, 0.5, okay.
Yeah, so if you have 8.0
Place 8.5.
and 8.1, halfway in between that would be 8.05.
Okay.
Does that make sense? Sorry, did I say it wrong? You weren't really listening to what I said.
I was listening.
Okay?
Yeah, you.
So the point is there's always some sort of uncertain measurement or some rounded, estimated measurement. So let's do some practice. No. Well, don't draw it. Just, I want you to put maybe like ruler and then A, B, C, and you're going to answer what, you're going to essentially do a measurement. shit, I want to get that away. All right, so first off, what is this a metric unit? Is this in inches? What do you think this is in? Not inches. What was that? This would be centimeters. And here's how I know this. The inches, between 8 inches and 9 inches, there are 16 tick marks between them. It's in sixteenths. 1/4, 1/2, 3/4 would be essentially 4/16, 8/16, and 12/16. Does that make sense? You see why the American units are quite a bit more challenging. Okay. This has how many tick marks? Should be 10, right? Okay. So it's easy to do decimals when it's in factors of 10, correct? All right, so you guys, it'll pop up here in a sec. Who wants to try their first attack at identifying where this would be? First of all, this would be, if this is 8 and 9, this would be 8.1, this would be 8.2, 8.3, 8. Does this make sense? Okay, who wants to try this? Shane? That's not a hand. Don't feel confident? You give me an X, because remember, you have to estimate one unknown number.
Yeah, sure.
What do you think?
8.13.
Ah, yes.
Oh my goodness.
Now, is that like 8.13? Is it 8.125? That still rounds up to 8.3. Okay, now, when you do this on a test or a quiz, if you're really close, I'll give it to you. Like if you said 8.14 or 8.12, I'd probably give it to you. But if you say 8.1 or if you say 8.19, I'm probably not going to give it to you. Does that make sense? Okay? Oh gosh. I bet you don't get this one right. Who wants to try? Go ahead, Ethan.
8.5.
Nope.
8.5.
Nope. Yes. It's going to be 8.50 because we know it's 8.5. What's my next uncertain digit? 0. Okay? You have to, even if it lands right on a tick mark, you still got to estimate. Now, is it easy to estimate what the next number is if it lands right on a tick mark? It's always 0. Okay? Carly, what do you think?
8.62.
Ah. Derek, how about this one?
8.80.
Yep. I think you guys are getting it. Not overly challenging. Oh. Moira?
9.07.
Yes. 9.00. We know it's on the 9. We know it's on the 0. We're going to go 1 on uncertain estimated digit. Okay, that was an easy one. This one. All right, let me just call on you. Rose, the first one. Why don't you take a crack at it?
0.7.
It's in the 0.7s.
Oh, 0.7.
0.7 what? Sorry. I didn't hear it.
0.717.
Yes. Now notice the scale was a little bit different. I mean, it's still 10 ticks, right? But we weren't from 7 to 8. We were from 0.7 to 0.8. So probably in millimeters. Okay. Shane, give it a try.
0.740.
Yes, very good. Ooh, this one's a little trickier. Carly.
0.758.
Yes. The suspense is killing me. Everett, tough one.
0.773.
Oh. Have I gotten everybody, or is there still someone who hasn't said any answer? Anybody not answered one? Sid?
0.800.
Alright. Yeah, we're gonna skip this one. Oh, let's try this one. Ooh, right off the bat, a little tricky. Mari? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, halfway in between. 8.5. Oh, hard one. Skip it. Right? 25.0? No goodness. 24.0? You don't have to write all these in. I think you guys are probably good for your notes. If you want, you can, I guess. That one I can't tell.
21.4, I
I got 21.3. That one's hard. Again, but I would have counted you wrong if you said 21.4. No. Ooh, a little different. Now we're not on a 10 scale, are we? Oh, that one's a tough one. Not that tough, but tougher. Anybody? Shane? I mean, Steven?
2.82.
I don't know. That's wrong. Well,
I was gonna say 2.7.
2.9 would be like probably.
Yeah.
okay, so I think what they're doing here is, you know it's 2. I think they're saying that the estimated digit is the first one since it's, I see what they're saying. But yeah, I would have said probably 2.8. I might have said 2.85. Would be right here. Maybe, is it halfway between 2.8 and 2.9? Close. Alright, so I'm guessing they're just going to one decimal place then. So then it becomes a lot easier, so I'm not going to do it. Now I'm going to do this, what's next here? I should say show that out. Okay. Accuracy. And precision. You need to tell me if it's accurate, precise, both, or neither. Don't say it out loud. Think for a second. Who thinks they have an answer? Everett? Yep. Now that is kind of close to being accurate. So that, I mean, that's. But if you can get that close to each other, you should probably be able to get.
Well, what if you're trying to go for that spot?
Well,
Then you'd be.
We're-
We're trying to go for the.
yeah, we're assuming we're trying to go for the center. Okay, all right. This one looks a little different. It's not a bullseye, is it?
No.
Okay, so this would be you hand timed, and you got an average of this, and then an actual precise electric gate timer got this. Accurate, precise, both, or neither. Even?
Precise.
But not accurate? Well, doesn't say. Yeah, it's precise. Not accurate. You're almost a whole second off. And when you have a device that can measure to the hundredth place, and you're a whole second off, That's not accurate, right? Now, if you had an instrument that could only measure to like the seconds, well, half a second off is not as big of a deal, is it? So it depends on your precision instrument, how precise your instrument is too. So context is key, not only biblically, but scientifically. Oh boy, I know what the book's gonna say. What's the book gonna say? Accurate. What Mr. Kramer is telling you is the right way. Luck. How can you be precise and not accurate? That drives me nuts. Okay. Alright, how about this one? I guess this is kind of more of what they're trying to get at here. If you look at the average, what does the average suggest? Accurate. But are they very precise?
No.
No, so Mr. Kramer would probably say neither, but the book would probably say, oh, okay, that was easy. What is it? And there's what it would look like on a timer. We're done.
Yeah.
Questions?
Tomorrow we have worship?
Do we have worksheet?
Tomorrow.
Yeah, prepare yourself.
Yes.
You like worksheets?
Love worship. Talk to us, help us.
Yeah, I can play time.
Yes.
2 days.
We only got 5 minutes. I mean, we're not playing silent ball.